Hello, this is Mr. Weideman at Functions Trig at Lafayette High School, and this is some warm-up problems that we have for section 6.5 in your textbook. I assigned these yesterday. We'll go over them here just a little bit. Your homework, let me have you turn those in. The 1 through 37 odd, we'll turn those in the next time we meet in class. All right, so let's take a look at these problems then. Let's take a look at number 10. These first set of problems, what they're really asking for is they're giving you a statement, and it's just straight substitution. They're saying if you put in x equal pi over 6, will it work? All right, so this is literally just a plug and chug. So let's substitute in pi over 6. Let's go to our unit circle then, and we see that cosine of pi over 6 is root 3 over 2. Sine of pi over 6 is 1/2. On the left side, let's give this a common denominator so we can combine like terms, and that's what we come up with on the right-hand side. On the left side, we do this, it's root 3 over 2, and these are not equal. That means pi over 6 is not a solution to this expression. Okay, let's move on to the next problem, number 20. Find all solutions. Okay, this one is pretty straightforward. We did these in class. What's the trick? Isolate the trigonometric expression, in this case sine x. So I subtract square root 3 from both sides, divide both sides by 2, and I get square root 3 over 2. All right, now we need to do a little bit inverse trigonometry. Let's go to our unit circle, and I'm trying to find an angle whose sine value, that would be the y-coordinate on the unit circle, is root 3 over 2. And there's two of them. All right, and we find that the sine of 4 pi over 3 and the sine of 5 pi over 3 will yield negative root 3 over 2. Now, 4 pi over 3 and 5 pi over 3 in anything coterminal will be a solution. Okay, so that's what this means right here. And anything coterminal with this. So just to kind of review, 4 pi over 3 plus, let's let n equal 1, 2 pi over 3, that's the same thing as 6 pi over 3. All right, so this is equal to 10 pi over 3. Now, what does that mean? That means that if I take 10 pi over 3 and plug it in to this equation, it'll work. Okay, and anything coterminal with 10 pi over 3 will work. That's what they mean by finding all solutions. Okay, let's see, this one here. Okay, this one's pretty straightforward. Just like we did before, I am isolating the sine term. Okay, so the 5 sine theta and 3 sine theta are like terms, so I can subtract those from each side, subtract -1 from each side, divide by 2, sine of 1/2. Okay, we're going to do exactly like we did before. I need to look on my unit circle and find out what angle has a sine of 1/2. It's pi over 6, 5 pi over 6, and anything coterminal with it. That's that n2 pi. Every time you spin around the circle and land back on pi over 6 or 5 pi over 6, it's a solution. Okay, last one. This one's a little bit different. They don't want all solutions. They just want all the solutions in one cycle. Okay, so how is this going to work? Kind of the same way. I need to isolate the trigonometric function with identity or algebra or something like this. And as you guys know, I hate reciprocal functions. So I know that cotangent and tangents are reciprocals of one of each other. So I'm going to take the reciprocal of each side of the equation. The reciprocal of cotangent is tangent. Okay, and there we go. Now, I need to find on the unit circle, where does the tangent equal to negative 1 over root 3? Okay, and those angles, let's rationalize the denominator because that's probably what we have in our unit circle. Okay, so 5 pi over 6 and 11 pi over 6 are going to equal negative root 3 over 3. Okay, so as before, we just say, okay, that's our solutions, 5 pi over 6 and 11 pi over 6. Not quite. We want the tangent of whatever input expression to equal 5 pi over 6. What do I mean by that? All right, so in our given equation, we want, whatever we plug in for theta, we want it to equal to 5 pi over 6. And whatever we plug in for theta, we want it to equal 11 pi over 6. Okay, and then we take the tangent 11 pi over 6, and we get our negative root 3 over 3. Okay, so that's what we want the expression to equal. In some examples that we have, the input thing is an entire polynomial. All right, whatever it is, we want that polynomial, we want that expression, in this case, to equal 5 pi over 6 or 11 pi over 6. So what I'm going to do now is the expression is equal to 5 pi over 6, but what does theta need to equal? So I multiply through by 2, and I divide by 3. That's my answer, 5 pi over 9, and not exactly coterminal, but kind of sort of coterminal is if I add this to 5 pi over 9, it'll be another solution. And I'm going to do the same thing with the other guy. Multiply through by 2, divide through by 3, and I get this. Okay, so those are all of my solutions. Okay, so if this said find all solutions, we would be done. However, it says I only want solutions that are bigger than 0 or less than 2 pi. Okay, I don't want infinite, all the solutions. I just want a specific set. All right, now it gets a little tedious. Okay, so let's look at these solutions again. All right, now I want just on the interval, let me back up. This guy, I want him just on the interval of there. Okay, well, theta equal 5 pi over 9. Is that on the interval? Yeah, sure is. No issues. Okay, now what about this next guy? 5 pi, and I'm going to let n equal 1. And what if I add 4 pi over 3? Because that is supposed to be another solution. Well, let's go ahead and add 4 pi over 3 to 5 pi over 9. And let's see if that is indeed a solution. So let's get a common denominator. And I got 17 pi over 9. And yeah, that's less than 2 pi. Okay, that is like 1 8/9 pi. All right, almost 2 pi, but not quite. And I think we can just determine by inspection, like if I add anything else to that again, like let n equal 2, and this is kind of a academic drill, that is definitely going to be too big. All right, it's much bigger than 2 pi. So that's not on the interval. Okay, all right, so I've got 2 solutions so far. Okay, now let's take a look at the 11 pi over 9 thingy. See what's going on at him. All right. So I'm going to do the same thing. Okay, 11 pi over 9. That's less than 2 pi. Definitely a solution. Let's let n equal 1. So 11 pi over 9 plus 4 pi over 3. Is that going to fit? Is that going to be on my interval? Well, let's give it a common denominator. And 23 pi over 9. That's too big. That's 2 and 5/9 pi. Okay, so that is not on the interval. So the answer to this is I have 3 solutions that will work in the original equation. 5 pi over 9. And what's all that icky garbage? There we go. 17 pi over 9 and 11 pi over 9. Okay, so hopefully your warm-up problems went well then. Thank you for your time.